Hey class, so today we'll be going over lesson 10.1 and lesson 10.2.
So now we're going to start off with lesson 10.1, ellipses. Now class, don't forget to put your phones away. Alright class, this here is an ellipse. As you can see, it's similar to a circle, but different in many ways, as it has a more oval-like shape. This is the center of the ellipse. This line right here is the major axis. It is the longer side of the ellipse. This is the minor axis, the shorter side. And these right here are the foci. Now ellipses can also be drawn like this, in a vertical, egg-like shape. Same rules apply. This is the center, this is the minor axis, the major axis, and the foci.
Are you getting this?
Yeah, I'm starting to get it.
So this right here is the general equation for the ellipse. So this right here is the general equation for the ellipse. A is supposed to represent half of the major axis, and B is supposed to represent half of the minor axis. Now for the egg-shaped ellipse, it's slightly different. Here, it's B, which is the minor axis here, and A, the major axis here.
Right. Now we'll go over the first example for ellipses. Using this equation, you must graph the ellipse and find the center, the vertices, and the foci. Now let's go over what we already know. We already know that this is going to be a horizontal ellipse because A is always going to be the bigger number. And in this equation, A squared is 16. Now if we square root that, we would come to the conclusion that A equals 4. And B would be 3. And to find C, which is the foci, you must do C squared equals A squared minus B squared. Now if we plug that in, we get C squared equals 16 minus 9. And C squared equals 7. So that means C is equal to the square root of 7, plus or minus. And that is your foci. The center, we already know as 0, 0, because x and y are alone, meaning that the x-coordinate for the center is 0, and the y-coordinate for the center is 0. Now to graph, we must use all the information that we know now and place it into a graph. Now this graph is a little rudimentary, but let's get into it. We already know that center is 0, 0, and that A is equal to 4. That means the vertices, the major vertices, are at 4, 0 and negative 4, 0. For the B, you're gonna go 3 units up and 3 units down. And now what you have to do is connect all these points to make an ellipse. The foci comes before the A. So, as you can see, C is equal to plus or minus the square root of 7. So, if we go on our calculator, we'll find that the square root of 7 is about 2.6. So, we're going to go back to our graph and go to about 2.6. And that right there is our foci.
Alright, thank you Freddie for your lesson on 10.1. Now we'll be going over 10.2, hyperbolas. First, you should start by getting used to the two standard equations for hyperbola that is horizontal and one that is vertical. Remember, a squared is always first. In this example, x squared is above a squared. That means the hyperbola will be on the x-axis. The distance between the center and the hyperbola depends on A. And in this one, it's the same thing, it's just on the y-axis.
I'm sorry.
What are you doing? Why are you on your phone? You don't remember? It's 1 point off every time you're on your phone.
In your jacket, sir.
Yeah. And what is this? You didn't even write any notes. Alright, whatever.
Disgusting.
pay attention here. Alright, now that we got that straightened out, we should go over asymptotes, which are another important factor of hyperbolas. It's represented by this dashed line creating an X in the graph, and it's found by these two formulas depending on if it's horizontal or vertical. The only difference is this fraction. You just flip the A and the B. The A and the B come from the original standard equation. The H is the X coordinate of the center, and the K is the Y coordinate of the center of the hyperbola and the asymptote. Hyperbola.
And now we're going to look at 10.2, hyperbola examples. Using the information from the graph, from the equation, we can determine that A is equal to 5, and B is equal to 6. It doesn't matter that B is bigger than A, because in hyperbolas it does not matter because A always comes first regardless. Now, to find out C, we need to plug it into the equation. C squared equals A squared plus B squared. Now if we plug that in, we get 25 plus 36. C squared is equal to 61. So that means C is equal to the square root of 61. And that's where our foci will be located. Okay, now for graphing, it's a little bit more complicated than the ellipse because there's a lot more to do and a lot more to graph. It's a little bit more complicated because there is more to graph. So now we use the information that we know and apply it to this graph. So we already know that A is equal to 5, and it's underneath the x-axis. So we're going to go 5 units from the center, which is 0, 0 once again, for both sides. And we're going to draw this line. It's the same thing, except we're going to consult the y-axis, and it's going to be a 6-unit thing. Okay, facts. Now that we have that out of the way, we can graph the foci. Once again, we know that the foci is the square root of 61. So consulting our calculator once again leads us to the conclusion that the square root of 61 is about 7.8. So that means, going back to our graph, and we're going to look for the point 7.8, which is about here, and here. Now, once we have all that out of the way, the last thing we need to do is to find out the equation of the asymptotes. Now, as you can see here, these are the equations. And since it is a horizontal facing hyperbola, we're going to consult this one. So y is going to be equal to plus or minus b over a times x. So that means the slope of the asymptotes is going to be 6 over 5 x. And basically what that is just the slope of the equation. So the slope of the asymptotes is going to be 6 over 5. Mm-hmm. And that is hyperbolas.
Alright, so Waleed, did you get all... What are you doing on your phone? I've told you countless times to get off your phone. What's this? Alright, that's it. I'm calling security. Security. Let's get him out. Come on, get up. Alright. Thanks for tuning in, class.